Hello everyone, in this lecture we are going to start a new chapter from class 10th chemistry, and that is study of compounds. The first compound that we are going to study is hydrogen chloride. So you know that hydrogen chloride is found in free state from volcanic eruption. It is also found in gastric juice of mammals. Now how do we prepare hydrogen chloride? How can we prepare hydrogen chloride? So there are various methods. The first is by direct addition of hydrogen and chlorine. So hydrogen gas and chlorine gas can react directly in the presence of diffused sunlight and they will form hydrogen chloride gas. So you have to remember, hydrogen chloride gas is formed by direct combination of hydrogen and chlorine gas. Now there is one more method. We can use a salt like KCl or NaCl to react with H2SO4, concentrated H2SO4 below 200 degrees Celsius. So it will form KHSO4 plus HCl. So hydrogen chloride can be prepared in this way, or barium chloride can react with H2SO4 to form barium sulfate and hydrogen chloride. So this is also a method of preparation of hydrogen chloride. Now the question is, how do we prepare hydrogen chloride in laboratory? So there is a method of preparation of hydrogen chloride in laboratory. Generally we use sodium chloride. We can also use potassium chloride and H2SO4 concentrated sulfuric acid for the preparation of hydrogen chloride. So this reaction will take place below 200 degrees Celsius and it will form NaHSO4, that is sodium hydrogen sulfate or sodium bisulfate plus HCl. So we have HCl here. Now this reaction can be used for preparation of hydrogen chloride in laboratory. Now this is the whole setup of the laboratory preparation of hydrogen. So what do we have? We have a round bottom flask in which we keep NaCl and we pour concentrated sulfuric acid from the top. So there are two openings in the flask, one for the entry of concentrated sulfuric acid and other for the exit of HCl gas which is formed here. So HCl gas will be formed. Why? Because NaCl will react with H2SO4. So heating is done. So with H2SO4 is poured from the thistle funnel. So it will form NaHSO4 plus HCl. So HCl gas will be evolved. Now because HCl gas which is evolved here is not purified, it is containing some moisture. So the second step that we do is drying of gas. Now before this, one more question may come. Why do we heat whole solution below 200 degrees Celsius? Why can't we heat it above 200 degrees Celsius? So you can see, if we heat it above 200 degrees Celsius, it will give Na2SO4, that is sodium sulfate and HCl. So sodium sulfate and HCl can be formed above 200 degrees Celsius. So what is the problem? The problem is that the sodium sulfate is less soluble as compared to sodium bisulfate. So sodium sulfate will deposit at the bottom of the flask. So because it deposits at the bottom of flask, it is very difficult to remove. So because it sticks at the bottom, sodium sulfate sticks at the bottom of the flask, we prevent the formation of sodium sulfate. So it is heated below 200 degrees Celsius. Now the next step after the formation of HCl gas is drying of gas. How do we dry the gas? So the gas is dried in concentrated H2SO4. So the gas which is evolved is passed through concentrated H2SO4. So this is concentrated H2SO4. So you know that concentrated sulfuric acid is a very good drying agent. So that's why we can use concentrated sulfuric acid. One more question may be asked, why do we use H2SO4 and not other drying agents like calcium oxide or P2O5, that is phosphorus pentoxide? So if we use calcium oxide, so calcium oxide will react with hydrogen chloride gas and it will result in the formation of calcium chloride and H2O. So you can see, because CaO, calcium oxide, which is a very good drying agent, it will react with HCl and it will form calcium chloride. So we cannot use this calcium oxide because it will react with the HCl. Now, in the same way, we cannot use P2O5, that is phosphorus pentoxide, because phosphorus pentoxide will react with HCl and it will form PoCl3 plus, so 3 HCl will be required, 3H PO3. So you can balance the reaction P2O5, then there will be 2 P2O5. Now, so this is how the reaction will take place. So because it reacts with HCl, P2O5 as well as calcium oxide. So calcium oxide will react with HCl as well as P2O5 will react with HCl. So it is not safe to use phosphorus pentoxide or calcium oxide as drying agent for HCl. So we use concentrated sulfuric acid for drying HCl. Now the last step, that is collection of the gas. Once we obtain the dry gas after passing the gas through concentrated sulfuric acid, the dry gas can be collected by upwards displacement of air, because we know that air is lighter than HCl gas, or you can say HCl gas is heavier than air. So it can be collected in a container which will remove the air. So it will displace the air upwards because HCl is heavier than air. So this is how the HCl gas is collected. The next topic is physical properties of HCl. So if we talk about color, odor or taste of HCl. So HCl is colorless gas with pungent odor and it has sour taste. The aqueous solution of HCl gas has sour taste and physiological nature. So it is highly corrosive in nature, and when it is inhaled, it causes burning sensation in nose and throat because it is highly corrosive in nature. Now, if we talk about its density, so it is about 1.27 times heavier than that of air. So its density is 1.2 times that of air. And if we talk about the solubility, it is highly soluble in water. So there are a few experiments to demonstrate the high density of HCl and high solubility of HCl in water. So one of them is this. So in this experiment, a candle is kept in a flask and this candle is burning in the flask. When HCl gas is poured in the flask, so a flask filled of HCl gas, so it is poured in the flask, what happens? The burning candle extinguishes. So what is the reason for this? Because the air escapes from the flask, because air is lighter than that of HCl gas. So HCl occupies the space inside this flask. So therefore the air is not there for combustion, and HCl is not a supporter of combustion. So therefore the burning candle will extinguish. So this proves that HCl is heavier than that of air. The next is solubility. So to prove the solubility, high solubility of HCl gas, we have an experiment that is called fountain experiment. So why it is called fountain experiment? Let's see. So in this experiment we have a blue litmus solution, then we have a round bottom flask inverted, and there are two openings. One is for jet tube and other is for droppers. So this dropper is filled with water. So what happens? This round bottom flask is filled with HCl gas. So whenever the dropper is squeezed, the water will move in the round bottom flask, and due to this the HCl gas will be absorbed by water. So because HCl gas present in the flask is absorbed by water, there will be partial vacuum in the flask, due to which the blue litmus solution will be sucked by jet tube, and here you will see the red fountain of the solution. So this proves that the HCl is highly soluble in water, so that's why the partial vacuum is created in the flask. And the second thing which can be proved by fountain experiment, that HCl is acidic in nature because it turns blue litmus solution red. So here you will not observe the blue fountain, but you will see the red fountain. So blue litmus is turned red, it means it is acidic in nature. So from fountain experiment we can prove two things, that HCl is acidic in nature and it is highly soluble in water. Now let's talk about the chemical properties of HCl. So if you talk about this combustibility, it is non-combustible, neither it supports the combustion. Now second is thermal dissociation. So it dissociates above 500 degrees Celsius. So HCl will be forming H2 and Cl2 gas. So hydrogen and chlorine gas will be formed above 500 degrees Celsius. The next is reaction with ammonia. So when HCl reacts with ammonia, it will form ammonium chloride. So HCl is a gas, similarly ammonia is also gas, but NH4Cl is solid, so it will form dense white fumes because it has white color. So it will form dense white fumes of ammonium chloride. Now if we talk about the reaction with metal, so with metal it will form corresponding metal chlorides and hydrogen gas will be liberated. For example, zinc with HCl will form zinc chloride and hydrogen. Magnesium will form magnesium chloride and hydrogen. Similarly, iron will form ferrous chloride and hydrogen. So you can see the metals will form corresponding chlorides and they will liberate hydrogen. Now the reaction with ammonia can be used for identification of HCl gas. Whenever HCl gas reacts with ammonia, it will form dense white fumes of ammonium chloride. So this can be used for identification of HCl gas. So this is all in this lecture. If you have any queries, you can ask your questions in comment box. Thank you very much.